In early 2011, Ion Torrent introduced the Ion Personal Genome Machine Sequencer, and within months it was the fastest-selling sequencer in the world. It enabled a complete sequencing run in as little as 90 minutes, and by the end of the year, throughput had increased by 100-fold. So where is there to go in 2012? Ion Torrent is going to do it all again, generating another 100-fold increase in throughput while still delivering results in just hours. If you look at the rate of improvement in sequencing throughput based on significant milestones in the development of NGS technology, it's clear that Ion Torrent is moving at a significantly faster rate than both 454 and Solexa technologies. Nothing gets better faster than Ion Torrent. The Ion PGM sequencer can sequence sets of genes or small genomes in as little as 90 minutes, far faster than sequencing technology like Illumina's MiSeq. For example, if you wanted to sequence 400 genes using Illumina's MiSeq and TrueSeq products, you would only get through 4 samples in a week. For the price of one MiSeq, you could buy 2 Ion PGM systems and sequence 20 samples in a week. The new Ion Proton Sequencer will use next-generation ion semiconductor sequencing technology to sequence entire human genomes in just hours. Moreover, the Ion Proton Sequencer will be able to analyze variants in the sequence data in the same day using a single standalone server. In contrast, optical-based sequencers run 6 genomes at a time over 11 days. At the end, they deliver a huge amount of data all at once, creating a giant analysis bottleneck that can take weeks more to work through and require extensive IT infrastructure. And again, the productivity difference between the two technologies is significant. The Ion Proton Sequencer is designed to sequence 600 human genomes in a year, compared to about 270 with an Illumina HiSeq sequencer. And for the cost of one HiSeq, you could buy 4 Ion Proton sequencers and raise your production to 2,400 genomes. Traditional optical technologies are slower than ion semiconductor sequencing because they're so complex. Optical technologies detect the 4 different nucleotides by chemically modifying them with different colored fluorescent molecules. It's like sticking a different colored light bulb on the end of each base. Lasers power the light bulbs and cameras take a picture as each base is added. Each light bulb must be removed before the next base is added to the growing DNA chain. Otherwise, it will continue to glow when the next base is added, and it may appear as an error. Performing all those steps for a single base incorporation takes 60 minutes on the Illumina HiSeq. Ion Torrent's technology is faster because it's basically as simple as a pH meter. It detects a change in pH due to the natural production of hydrogen ions when a nucleotide is incorporated. It uses natural biochemistry. No fluorescent or chemiluminescent tags, no lasers, no cutting off of light bulbs. The entire process, from incorporation to detection, takes just 36 seconds for a single base. The other big advantage ion semiconductor sequencing has over optical-based sequencing is its ability to leverage Moore's law. Formulated by Gordon Moore, a co-founder of Intel, the law states that semiconductor chip performance doubles every 18 months. Over time, the impact of Moore's law has been huge. In 1976, the most powerful commercial computer was the Cray 1. It could do 86 million computations per second, cost $25 million, and weighed 5 tons. 35 years later, an iPad 2 can do 1.7 billion computations per second, costs $499, and weighs 1.35 pounds. Ion Torrent has taken Moore's law and applied it to sequencing. As a result, every generation of our semiconductor chips gets both denser and faster. That's allowed Ion Torrent to massively increase the throughput capacity of its chips without a commensurate increase in sequencing time. Our first chip can sequence a bacterial genome in just 90 minutes. Our newest chip, the Ion Proton 2, we'll be able to sequence thousands of times that amount of DNA, an entire human genome, in just a few hours. The sequencing output of Ion Torrent's chips has been increasing far faster than Moore's law. The reason is that our first chips were made in a factory built in the mid-1990s. A year after those chips were launched, we started producing ion proton chips in a much newer factory. In effect, Ion Torrent jumped over decades of accumulated Moore's law advances in just a year, and that's what will enable another 100-fold increase in throughput this year. Ion Torrent is scaling faster than any other technology because it's taken the DNA sequencer, up to now a big expensive box filled with lasers, cameras, and scanners, and put it on a disposable semiconductor chip. Once semiconductor technology enters an industry, phones, books, music, photography, analog technology cannot keep up. Just as the microprocessor enabled desktop computing to displace big, expensive mainframe computers, Ion Torrent semiconductor technology is democratizing sequencing, putting it within the reach of any lab or clinic.